Welcome to our online panel debate, hosted by IT Pro and Pentaho. I'm Sarah Driscoll, and I'm joined by Wael El-Rafai from Pentaho and technology writer and broadcaster René Millman. Today, we're going to be discussing how organisations can drive value quickly from their data by conducting effective data preparation and integration. Don't forget, we want you to be part of this debate as well, so please submit your questions through the viewing console and we'll come to those at the end. 90% of the world's data has been produced in the last 2 years, but only 0.5% of that data is ever analysed. The potential for businesses to analyse their own data is huge, and the benefits are far-reaching. But the cycle from data to analytics is long and laborious because data scientists spend countless hours ensuring the data is aggregated in the right way. According to Ventata Research, businesses spend 46% of their time preparing the data and 52% of their time checking for data quality and consistency. This means IT teams responsible for feeding data to the business can spend their entire time on just these two tasks. This isn't just unscalable, it's inefficient. Add to this a lack of IT resources, and data preparation and integration becomes a challenge for companies looking at doing data analytics. Today, we'll discuss why preparing and integrating the data ready for the analytics engine is so time-consuming, and how companies can look to shorten this cycle, and the impact of new types of data such as IoT and social information is having on data integration and preparation. While, René, it would be great if you could both introduce yourselves, give a little background, and maybe just talk a quick overview on why you guys think data is so important.
Okay, thank you, Sarah. My name is Wael El-Rafai. I'm the Director of Enterprise Solutions at Pentaho. My background, I've spent the last 10 years in big data integration, data science, machine learning, artificial intelligence. And the reason data is so important ultimately is that we want to base our decisions on information, right? We would never assume that we can do better work, make better decisions with less information or poorer quality information. So it's that simple. It's about data-based decision making.
Thank you.
Yeah, I'm René Millman. I'm a writer and broadcaster. I've been writing mainly about infrastructure and security over the last couple of decades, and over the last few years that's been increasingly based around cloud, big data, and more recently the Internet of Things. I think big data is important because a lot of organisations now are, their lifeblood is information. So they have to be able to process, gather the data, process it, and act upon it to gain a business advantage or just to keep in business. So I think information and big data is going to be increasingly important over the next few years.
Yeah, definitely. René, to come to you first, where do you think we are in terms of a general understanding of data analytics?
I think that nowadays most organisations get big data. They understand what it's all about. Even when they don't think they are using it now, I'm going to underline that they don't think they use it, because pretty much they do, even if they're not realising it. As I said before, the trends such as cloud and the Internet of Things means we're going to get ever more amounts of data being generated, and this needs to be stored and processed and acted upon. So I think up until now this has been the case for the large organisations, but this is percolating down through into the mid-market, where they realise that they too have to work on information and process it and analyse it for insight.
Yeah. Well, is that something that you'd agree with? It's sort of penetrating further down?
Yeah, what I would say is that, well, I'll tell you why I think there's an evolution here. So communication, computation, and storage have become effectively free, right? As a result, we capture a lot more data. We're talking about IoT. We've dramatically increased the amount of data we capture. This has had an interesting sort of positive feedback cycle. It means that the applied mathematics, machine learning, AI, all that stuff has improved dramatically, which means we can make much better decisions. So while companies have really gotten the hang of the, let's say, sort of basic data analytics, the data warehousing, which I think of as the look back technologies, understanding what happened in the past technologies. The prediction technologies are just really starting to be understood.
And how do you think, a question for both of you, how do you think that's going to change and develop over the next several years?
Well, I think that, like I said, the mathematics of it is improving every day, right? The big data platforms, right? When we talk about big data, we often mean Hadoop. You know, the core idea behind those is to lower the cost of storage and computation, right? And the core idea of many like GUI-based data integration, data prep tools, the core idea is that the storage and execution layers are sort of abstracted away. That no matter what the underlying layers are, the business logic layer looks the same. So I think we're going to see more and more abstraction. We're going to see those tools take away more and more of the headache of dealing with systems like Hadoop.
Yeah. What do you think, René?
Well, I think it's interesting because you've got the the increased automation thing. I think what we're going to see is the need for better preparation of data, because if you're going to teach like a machine learning system how to then sort of process and get insights out of that, then you've got to have well prepared data in the first place to make sure that you don't end up teaching it the wrong things about how to act on the data.
So maybe it's automation of data prep you want, right?
Yeah.
You want systems which can look at the data and understand where are the flaws, what is incorrect, and how can I correct it?
Yeah, exactly.
Or maybe even learn when a human being can go in there. Maybe the system can say, hey, there's a problem here. The human being can go make a correction, and maybe then the machine can make the correction in other places.
Exactly, you can learn from that. But again, there's going to be a human element to this. It's just a way of kind of leveraging machine learning in order to speed up that process.
Yeah, definitely. In terms of the advantages, especially from a kind of business perspective, that big data can bring, can you kind of expand on some of the advantages that it can bring, especially maybe for companies, as we mentioned earlier, kind of lower down the spectrum in the mid-market? What advantages big data analytics can bring?
I've got a few thoughts. So let's think about companies that are working in really low margin industries, let's say in manufacturing. I'll wrap up a few things together here. Let's think about big data and IoT, right? So big data is just a generic term we use to cover scalable technologies for data processing, right? IoT, we're talking about low-cost communications and transmission of data from low-cost sensors, yeah? So companies in the mid-market that are low margin, companies that do manufacturing, being able to capture that data is going to allow them to do things like predictive maintenance, things like schedule optimization and asset optimization in general, energy reduction, and so on. So I think they're going to see, especially in those low margin industries, a 2% change in their business, a 2% reduction in energy consumption is earth shattering for them. It's huge. It's huge. So I think that's where they're going to see a huge move for them.
Yeah, I think I pretty much agree with all your points there. I think raw data isn't much use to. It's
unintelligent, right?
To anyone. It's just data. It's what you do with the data that's important, and you have to get it properly prepared, properly processed, and then you can run the analytics tools to gain the insights. I mean, like I said, come back to the Internet of Things. If we've got sensors around, a shop floor or a factory, you're getting a load of information data, but you've got to have the right information to work out whether or not a machine's about to fail and needs a repairing, or you're a retailer and you're looking for the trends that will kind of give you like a 0.5% boost in revenues, because especially for retailers, 0.5% is a huge amount. So being able to look at that data and process it to get you that little bit of an edge on the competition is going to be, it's definitely going to be the business advantage there.
Yeah, definitely. You both mentioned a couple of vertical sectors there, retail and manufacturing. Are there any other sectors you feel are benefiting kind of specifically from big data and data analytics? I mean, what about sort of pharmaceuticals or financial services? How are those guys using this?
So financial services, I think, has been one of the leaders in this. Let's take a step back actually for 1 second, because big data is about just processing of huge amounts of data. The outcome, which might be predictive maintenance and things like that, this is not brand new, right? This has been around for 60, 70 years, arguably for thousands of years, right? The techniques are what's improved.
Yeah.
So financial services are definitely using these big data techniques. They're using it in compliance and risk and treasury and global banking and retail banking, commercial banking. All that stuff is using it. In pharma, they're using it in drug testing and doing an analytics prediction on whether or not a particular drug is going to make it through human trials and so on.
René, can you see any kind of within the vertical sectors? Are there any other sectors you think are particularly apt for using data analytics?
I think what Wael said, they're very good use cases. I would add to that things like agricultural things, agricultural industry. Farmers with sensors in the field get forward intel about the status or condition of plants, animals, or whatever, and be able to kind of get an idea of if something's about to go wrong.
Yeah.
They can. So
it's a bit proactive, isn't it?
Be more proactive and maybe sort of save a situation which otherwise would be impossible to salvage. So that's just another thing off the top of my head. Really.
Yeah. So there's two things there, right? There's the big data where we're doing this sort of batch processing of a whole universe, and there's also this sort of stream analytics here. So there's that real-time decision making, that complex event processing, and then there's separate from that big data, or like the large volume data analysis.
Yeah. We've talked about some of the advantages that doing big data analytics can give. What are some of the barriers to adoption, René, do you think that companies are finding at the moment?
Well, I think cost is becoming less of an issue because more products are coming onto the market. But I just think the main issue will be the volume of data. It's just going to get bigger. I can't see it tailing off anytime soon. So I think the main issue is like you're going to get so overloaded with data, you're not going to quite know what to do with it unless you have in place the processes to filter, process, and prepare the data. So I think that's one of the main barriers I see.
I would agree that's a barrier. I would think the main barrier, in my experience so far, has been complexity. Not complexity of the data itself, but complexity of the sort of systems we have for processing.
Yeah.
So, if we step back, let's say if you wanted to, these big data systems, oftentimes we mean Hadoop, right? If you want to write something in MapReduce, you need to know maybe MapReduce and Yarn and Oozie and Flume and Kafka and Spark and who knows how many other things you need to know, Java and Scala and Python. So I think we're going to see an evolution here, an abstraction, which we've seen throughout the whole computer age, well, throughout human history. But, if you go back 50 years, computers were coded very manually, single instructions about pushing and pulling memory from one bank to another. And today, all that stuff is sort of automated, abstracted away from us. The system handles it. So I think one of the big problems we face today is abstraction. We need those sort of systems which can handle all that underlying complexity and automate a lot of the data prep, a lot of the analysis and data movement and so on.
So just to kind of move on to data preparation and integration, what makes getting that right so important?
Okay, so when you want to use your data, what you need to be able to understand is whether the data is accurate, whether it's complete. You want to be able, I usually think of this as turning data to information.
Yeah.
So what we want to do is start with data, convert it to information, which is after you've checked it for accuracy and completeness and so on, maybe blended it with some other data, then finally convert that to knowledge. The information to knowledge piece I think of as the machine learning, artificial intelligence piece. Yeah. But the data to information piece, that's about data prep and blending and so on. It's important because two different sensors might produce two different timestamps. If you just put that data together without having prepared the data, done the right timestamp alignment and things like that, or one might be in kilometers, one might be in miles. Without standardizing all these things and modeling the data so that it can be used, the data is effectively useless. You were talking earlier, one of you mentioned how much data is not being used. I think you quoted Ventana research, right? That only 0.5% of data is actually being used. Well, a big part of that is the enormous burden around data prep. So what you really want to see, and I think where a lot of us in industry are evolving, is around automation of data prep and abstracting away a lot of that complexity.
René, what do you think? What makes it getting it right so important? I sort of mentioned earlier about the time it's taking at the moment. Do you think that's a big issue?
Yeah, I think so. I think when it comes to this data prep processing, I think it does look to me that we're not in a position to process all the data. I think that's a very small amount of data. On the flip side, I don't think we want to process 100% of the data, or we don't want to use 100% of the data, because 100% of the data may not be accurate.
But is that part of the preparation process, knowing which data, which elements of data you actually want to put forward to go into the analytics engine? Is that?
I think that's part of the. Let me step back a little bit to explain what I would do here. I've seen this in a lot of IoT cases, especially because sensors are dumb, right? They just produce a signal over and over. Let's say the signal is door open, door open, door open. It's coming out 100 times a second. You don't need all of that data, right? But what you might need to do is to be able to build a model that represents the world, right? That represents the way the system is working. To be able to do that effectively, at the start at least, you need to be able to gather all that data. So maybe you need to automate the capture of all that data, build your models to tell you which particular signals, which particular sensors are important, and then you can choose what you do and don't want to prep. Then it might be okay to go from 100% data capture down to 0.5%, right? Yeah. But I think we need to first capture it all and automate some of the analysis so that we know where to look in the first place. Which, by the way, is the way our brains work, right? Yeah.
I just think I just thought something off the top of my head here is that when you talk about data and information, it's a bit kind of like what they say about the map is not the territory. The territory is that, but the map is just a representation, a simple representation of what we need, the information we just need to then get from A to B. We don't want a complete kind of picture of it, because that would be meaningless to us. But if we can make the map, then we know we can go, right, okay, here's where we are, here's where we want to be, that's the way through. Yeah.
It's about making a good enough model of the world. Yeah. Right? So ultimately, when you're trying to reduce that amount of data, the term we use often is heuristics. So as a human being, we have your eyes, your ears, your smell, your taste, your touch, etc. You're capturing all this sensory input all the time. I'm sitting in this room, I'm hearing an air conditioner, I'm hearing your voice. How can I tell the two apart? Because both are just vibrating molecules, right? So the whole, the analog in data prep is being able to take all that data and figure out what is what, right? Yeah. Simplify the model of the world. And so that's why I think data prep and data prep automation is so important. Yeah. If the systems can't do some of their own prep, some of their own automation, then you're going to have a hard time ever building a complete model of the world with all the data.
Yeah. So that kind of leads on nicely to my next question, which is when we think about data preparation and integration, what do you think companies find challenging? Is it the manual aspect and the lack of automation? Is that kind of one area, would you say?
For the companies that are struggling with amount of data, so when we talk about big data, we mentioned Hadoop, sort of a technical view, but the sort of slightly more businessy view we've been using are the V's, right? Variety, the volume, and the velocity. Yeah, exactly. So volume in of itself is only a problem of computational scaling, which Hadoop solves. Variety is velocity again is just one of volume of scaling, but variety is the one that really becomes important here. One of the big challenges is when a company has a huge variety of data, blending that all and modeling that all into a cohesive view of the world is highly complex.
You mean data from various sources?
Yes,
so
data
any
from
kind
thousands
of
of
IT
sources.
systems, IoT systems, social information, all those kinds of
Exactly. So traditional systems, whether it's point of sale or customer relationship management, or ERP, and so on, and then sort of newer systems like IoT or social media and so on, blending all these, what you might have potentially thousands of sources into one coherent view of the world, what we used to call Customer 360, for instance. That is extremely complex. And I think, again, the difficulties are hand coding and lack of automation.
Can you expand a bit when you say hand coding? You mean manually coding it all?
Yeah, so oftentimes, if you want to code something, you have to write some Java or Python, or if you're old school, maybe you're writing in Perl or something. But you're writing all these different programming languages. Now, I've been programming since I was 5 years old. But if you give me 1,000 lines of code, it's always going to take me a day or two to figure out what's going on. despite my experience programming, right? The advantage with sort of GUI-based tools, drag and drop type tools, is that they're almost self-documenting, right? So you can get rid of the hand cranking, all that hand coding, and you can just look at the system and figure out right away what it is that it's doing, right? Maybe not every detail, but to your point, it's a good enough representation of the world.
It's a model.
It's a map.
Yeah, it's a map.
Renaud, how do you feel? What do you think some of the challenges are around data preparation and integration?
Well, I think another point here is that in the act of preparing your data, I think that will bring up sort of issues about the data itself. It may be in the course of preparing data, even before you got to any kind of analysis, there's like sort of pre-analysis that it might, in that preparation data, you might find that there's issues with the data collection itself. Even before you go on to like analysing for business insight, you might just go, oh, actually, are these sensors working right, or have we what are we getting from the social media? Is that really telling us what we need to know? Are we that kind of thing? So I think it could. In preparation of the data, you'll get some sort of early. I think you'd get some early warning signs.
Sure. So when we talk about data prep, we mean things like ingesting, and to your point, cleansing, right? Finding out when data is meaningless. When I say meaningless, I mean because the sensor is broken, for instance.
Yeah.
And knowing how to filter that out.
Yeah.
That's one of the key tasks of data prep. Finding out data that's unstable or something.
And do you think that that's one of the challenges that companies are finding, that they think they're ready to do, put all this data through the analytics engine, and then suddenly, hang on a minute, when they start to do the preparation, actually what's happening is they're finding out they haven't got the right sources, they haven't got the right, kind of the way it's being inputted is incorrect, or those kinds of elements. Are they kind of barriers that people are coming up against?
I wouldn't even call that a barrier, though. That's a discovery, right? So when you find out there's a problem in the data, that might indicate a problem in the system, right? It could be that the sensor is broken, but that's kind of the same way of going about. Imagine if you're in your car and the check engine light comes on, and you go to the mechanic, and the mechanic says, "Oh, the light's broken."
Yeah.
Well, that's not how we want to look at it. When the data has something seriously wrong in it, what we'd rather say is, well, could it be that the engine is damaged?
Yeah. So it's almost in a way more of a hindrance than a complete barrier.
Yeah.
It's just gonna slow you down.
Yeah.
If there's something wrong with the data.
But that's part of the process, right? So when we talk about big data, going back to the point that I was talking about earlier, in the old world we talked about operationalizing the data warehouse. But the data warehouse was great when what you had was shared KPIs, common goals, common definitions, and you knew who was reporting on what. In the big data world, we have a little bit less of that. It's not pure research, but there is some element of R&D, right? So discovering what things are broken, discovering what correlations don't make sense or what values don't make sense, that's part of the improvement process.
Yeah.
So if you discover that a sensor is broken, well, it might mean you have to cleanse that data out, but what it probably means you should do is fix the sensor.
Yeah.
And maybe discover something about the system. Why did the sensor break?
Yeah.
I think it's important to realise that maybe, like I said, what you might consider a barrier isn't actually a barrier. It's just part of the process, isn't it?
Potentially an opportunity.
And a potential opportunity. Yeah.
It might be indicator of a problem.
Yeah. So we've talked about some of the kind of areas that companies would find challenging. What about ways that they can overcome those challenges? You mentioned while the hand coding, and we've briefly touched on automation. Is automation one way of kind of overcoming some of those challenges around hand coding and the sort of laborious process that it takes to prep the data?
Yeah, I would say that the potentially number one, way that we can overcome those complexities, especially when we have a huge variety, different types, different data sources, is automation.
Are there limits to it though?
There are some mathematical complexities that create limits to what you can automate. Yes, that's definitely, there are some limits. But without going into a lengthy discussion of how you can automate data modeling, most of what we do today could be automated, right? And that's, you see that in the industry. Many
Yeah.
companies are pursuing that, right? A lot of what we do today can be automated.
Well, yeah, I think if you're going to overcome these issues, you have to. I do think you have to have the mindset of taking an evidence-based approach, and I think that's pretty much good advice across the board, really. You just got to look at all the evidence, and then kind of think about what needs to be done, where are the issues, and then move on from that. I don't think there's much more to it than that. Well, there is a lot more to it, but there's not much more I can add from that. I can, like I said, you can go do a deep dive into this, and
it's data-driven decision making.
Yeah.
Right. And at the end of the day, anytime somebody says we don't need big data, what you're saying is I don't need to process huge amounts of data, right? Or we're not going to capture all that data. But then I would respond with, well, what's the rationale for that? I mean, you have this data, you're not going to look at it, and the rationale is what? That you think you're already doing things perfectly? Yeah, I mean, it's possible that you've arrived by trial and error at the perfect solution.
Yeah.
It's much more possible that there are more insights you could get, right? And big data isn't just about getting more insights from your existing data, it's also about creating new revenue streams, right?
Being able to spot those opportunities with the predictive analysis that...
Or
the big data
monetizing
can
the data
drive.
that you're producing. And the one that I always think about is, Goldcorp, have you ever heard of that? This is about open data. They were basically bankrupt, a gold mining company, I believe in Canada. They took all their mining data, they made it public, and they offered $1 million to whoever, they just put it on their website. $1 million whoever discovers a big seam. And they were, I think, for the next 5 years, the largest gold mining company on the planet. They found huge things, right? And that was about capturing more data and even making it open.
Yeah.
Now, open data is a whole separate discussion, and I think that company went bankrupt eventually, so it's not the best example. But
for that short time, they were
flying high.
For 5-10 years, they were flying high.
Yeah.
So, in terms of the benefits that doing, high level kind of and improving data preparation and integration, what do you think the top 2 benefits to doing it, sort of improved data preparation are? Is it mostly a time thing?
So a big part of it's time. What you really want to do is, some people call it data prep, some call it data engineering. Let's just call it data prep for now. What you want to do is take people out of that low value work and let them focus on the high value stuff, right? Let them focus on the data analysis.
Yeah.
Human beings are great with analysis for certain types of analysis, right? So let the computers handle all that, the menial type of labor, right? So I think the main thing is what allows us to refocus on the things where we can get some real value and let the computers handle the trivial stuff.
Rene, would you agree with that?
Well, yeah, I agree with that. Automation is all about trying to move the humans higher up the stack to where we think we can add value. I mean, the whole idea is being able to add value to an organisation, gaining a business advantage. So yeah, again, all I can say is that automation is key here, but also making sure that the automation is working in the right way. Again, garbage in, garbage out. If you build on iffy foundations, then your analysis is equally going to be iffy. So I think you do have to kind of go make it an iterative process in order to figure out how you can improve it, and then that's the safest way for an organisation to move up the stack and look at the bigger picture.
That's a good point you raised there. How can businesses actually ready themselves to start this process? What's the kind of, I guess, the process to start the process, as it were?
That's depends how you want to come at it, right? So first there has to be a commitment to data-driven decision-making, I would say first.
From a board level perspective, do you
I think in
it
general,
needs to go that high?
Probably, yeah. Probably at the board level, CDO or CIO or CTO, there needs to be an agreement that data-driven decision-making is an imperative, that everything should be driven by data, right? What I don't mean you should be lost in the morass, lost in the details, but you should have a directive that everything is driven by data. And then you can do an assessment. Where I think about when I think about this sort of problem is I think, well, what could we do if we had perfect, universal, and timely information? If all the information we had was prepared and perfect, so to speak, I don't mean 100% perfect, but was largely good, universal, in the modern world with low-cost communications technologies and whatnot, any data that's available to anyone, anywhere in the world is available to you, right? Now, you might have to pay for it, but it's available to you, and finally, timely. It's available in the time that you need it to make the decision.
Yeah.
So, if you make the decision to be data-driven, then I think you should decide, well, if I had perfect, universal, and timely information, what could I do? And now we can talk about going out there and getting the data.
So almost look at your goal first and then work backwards.
Absolutely. Or at least say that, you know what, it doesn't have to be that, oh, the goal is to fix this schedule. It might be say that, oh, my goal is to find out whether the way we've scheduled this or the way we're using this piece of machinery is optimal.
Yeah.
I want to find out if that's true. Now, the only real way of finding out is capturing all the data, not about how the thing is supposed to function, but how it's actually functioning. Not about how it's supposed to be used, but how it's actually being used.
Yeah.
Capturing that data, then you can do the analysis. Then you can find out, whether or not you're meeting your goals.
Yeah. René, when we just talked about the readiness there, but do you think there's a priority of things that companies need to do first when kind of readying themselves for data preparation and integration?
Well, I think just what Will said. It's I think you've got to have the board on your side. I think this is too important to just go off on a limb and then just hope that the rest of the organisations are going to just go, well, you're right.
Do you think that happens now? Do you think there are kind of mavericks who go out and start doing maybe hand coding, or they want to find something out, so they start? And I guess that can cause a little bit of a few challenges within organisations these days. So
what are we calling this? Citizen data scientist now? That's been the term that's been going around, citizen data scientist or maverick data scientist. I don't want to discourage people from doing that kind of thing. I think it's good to take initiative and whatnot. But unless there's a clear goal, unless there's a rationale or an approach you want to take, I think there's a lot of potential for mayhem. Yeah. So I'm not against citizen data science. I think it's a great thing to be doing, but I think there should be a clear directive. In addition to that, there should be a clear directive within the organization that we are a data-driven organization. That way you don't repeat work. Because if everybody's doing their own data science, maybe everyone's doing their own data prep as well. Maybe everyone's doing their own data modeling, and maybe you're repeating the work 100 times in the organization. I think you've got to steer a course between being a data scientist and perhaps being a data alchemist. You don't want to. You don't want to take. You don't want to try and turn data lead into gold and you can't do it. Yeah. Again, I think there are merits to this kind of maverick behaviour. If what you're thinking is accurate and it turns out to be true. But I do think you've got to take stock. You might have somebody who says, I think X. Well, you've got to foster these ideas, but like we've said time and time before in this discussion, you've got to take an evidence-based approach. Yeah. So, again, I think you've got to work out whether or not it's a good idea, and if you think it really is a good idea, you've talked to other people in the organisation, then take it to the board and say, well, this is what I think we can do, and then we can go and prepare the data in that way. So again, I think once you've got sort of a bit of like the wisdom of crowds here, once you've got a few people in agreement, I think you can be safe to like move on and take those steps. So maybe the thing I'd have to give this a little more thought, but I think that maybe a data prep maverick, a data engineer maverick, or a citizen data prep makes a lot of sense. Yeah. Right? Because that is a sort of maybe a well-known problem, how to fix a particular piece of data, might be well-known, well understood by people throughout the organization. Yeah. When we say data scientist, the problem is now all of a sudden we're applying mathematics or complex techniques to it. And that often does require specialized training, right? Yeah. So, maybe there's going to be a day where we can automate that, or we can, democratize access to that. I think we're going to get there in a couple of years. But right now, I think citizen data prep actually a pretty noble, pretty good goal.
Yeah, I think we're just at that early stage, because I do think that at some point that will become automated.
Yeah.
And
I guess it's how an IT manager kind of controls it but doesn't stifle it. It's that balance, isn't it?
Yeah. Well, so providing audit and lineage, understanding where the data is, who's using it, what are they doing with it, and so on.
Just one last question before we go to the audience questions. We touched on this earlier. There are lots of new types of data around. René, I know you particularly mentioned IoT. We've talked about the social. What kind of impact is that having on data preparation and integration?
So those data types are really complex. Let's take into account social, for instance, right? When you have social media data, well, social media data might be a tweet. What is it, 140 characters?
Yeah, 140 characters.
Yeah, something, a fairly small number of characters, but it's pretty open form. So you might have to start by saying, what is it I want to gather? What is the information I want to gather from this tweet? If it's location data, it might be fairly simple, right?
Yeah, that would be
What
great.
if it's sentiment data? Sentiment data is more complex. It requires supervised learning techniques. Or
There's nuances as well.
Yeah, exactly. And there's all these different pieces of information that are kind of unstructured, right? So the data prep task might also include an element of data science to it. So in those types of data, it becomes much more complex. And when we talk about sensor data, it's even, it's just as complex, I think, because data is very high velocity and might have very abstract sort of formats, ones and zeros only, potentially, and so on. So I think that these sort of new media types and IoT data types create a much bigger challenge, and they're much greater in volume.
Yeah, I think on the social side, nuance and context can be so easily lost, and it's easily lost to humans. So expecting automation to somehow get to the right answer where we haven't been able to do in thousands of years of existence is going to be a tremendous ask.
There's a funny thing I just had happen with regards to that when we talk about nuance. I don't know if anyone has downloaded the new Apple operating system, Apple iOS on their phone, but if you're in the SMS function and you type congrats, it puts confetti on the screen now, right? Now, when it comes to nuance, the other day I was having a sarcastic conversation with somebody, and they said congrats, and all of a sudden it blows up confetti on the screen. Yeah. If it had really understood nuance, that wouldn't have happened.
Yeah, so beware.
Yeah, exactly. Right, thank you guys. I'm going to take some questions from the audience. First question's come in. I'm starting my data strategy from scratch. What are my top 3 priorities? Great question.
Okay, so let's discuss what's meant by data strategy, I guess. If data strategy is a technical strategy, assuming there's already a sort of a board level decision that we're going to use data to make decisions, then what we need to start with is infrastructure and tooling, right? What different types of data are out there? What different types of data do we plan to get? Yeah. And what are the best in class tools for it? How do we limit the amount of hand coding? So top 3 priorities, I would say there's nothing terribly genius here about it. Having people who can do the analysis, which might be data science, having the right infrastructure, and making sure that the system is sufficiently abstracted so that it's going to last until next year, right? Or until 5 years or 10 years from now. The reason I say this, just to clarify a little bit, when we talk about the big data space, 3 years ago we only talked about MapReduce. 2 years ago we only talked about Spark. Last year we're talking about Flink. Who knows what it's going to be next year, right? So I think one of the top priorities has to be abstraction, and making sure you have the people who can do the data science and then the infrastructure.
Really?
Well, I think I'd add to that is that having the confidence of senior management and the board. I think if you're going to have a data strategy, you have to be in a position to explain it clearly and what the advantages are and what the challenges are. If the board isn't convinced, it's either A, bad idea, or B, you haven't really explained yourself properly.
You know what we haven't even discussed?
What?
The security around it. I mean, depending on the type of data you're dealing with, the security implications are...
That is a whole...
That's a whole other webinar,
whole other discussion. a massive discussion.
Yeah, so the person who asked that question, I wish I could give you a concise 3 items for data strategy.
We need another webinar about that.
Exactly.
We need a little time to sit
Probably
down and
another 2 or
discuss it.
3.
Yes.
Fabulous. The next question's come in. So, what are the most critical data preparation processes for an SME?
That's well. I think it's a bit different with SMEs because normally speaking, it's normally down to the issues there are of cost. So it's kind of you've got to be a bit more prepared.
Tactical.
Yes, tactical. You have to be tactical rather than strategic, because you're looking for what's going to make the most difference.
Exactly, with limited resources.
With limited resources, so you've got to act a bit more tactically rather than strategically, which you could do in a larger organisation.
So then, what you're really looking for is to reduce the complexity of the system, right? Make it self-service, I think.
Well, yeah, that's true because you don't have the resources to hand. So yeah, it's a question of resources.
Yeah.
As always with SMEs.
Yeah, and actually. While that's you mentioned self-service, the next question's actually come in about that, which is some organisations speak about a self-service data preparation model. What is that, and what are the advantages of it?
Yeah, so there's a lot of things to this, but let's kind of boil it down. When we talk about data models, we're talking about how the data is stored, whether it's in multiple tables or one file or whatever all it is. When we talk about a self-service data prep model, we're talking about a system where all the data is gathered and the person can sort of drag and drop and say what it is that they want and do the processing on demand. Run the entire data prep and analytic workflow on demand. Yeah. And this is important because the point you made earlier about only a small amount of data being processed, 0.5% out of the huge volume of data that's available, there are 2 rationales behind that. One of them is that we haven't built the data prep and all of that. But the second one is that the data volumes are so enormous, it might not make sense to look at all the data, right? You might only want to cherry pick a few pieces of data and then provide self-service data prep. So the person can sort of drag and drop what data sets they want, what attributes, columns, etc. they want, and then sort of hit go, and the system runs an entire analytic process end to end. It's actually what we've been calling a streamlined data refinery.
Renee, do you have the same?
Well, it sounds a lot like a supermarket because the supermarket has everything you need, but you're the customer and you have certain requirements, so you just need to be able to kind of work your way around that system and picking and choosing stuff. And again, it's pretty much down to what you want out of it. Really, so yeah, I think it's
so a big part of the rationale behind this is because preparing all that data a priori, preparing it all in advance, is computationally enormously expensive
and time-consuming.
And
resource-intensive.
Extremely resource-intensive. And if you want to get rid of that, you want to be able to do it. If it's only ever going to be a tiny bit of the data you're looking at, then a great way of doing this is a sort of on-demand data prep. I'm actually reminded of a case we're dealing with. One of our customers, I'm 99% sure it's publicly referenceable, is a self-regulatory organization called FINRA in the US. They've got billions upon billions of transactions, and what they're looking for is fraud. Now they've got billions and billions of transactions, and doing all that data analysis in advance is computationally enormously expensive. They're not looking for a needle in a haystack. They're looking for a bent needle in a stack of needles, right? They're looking for something very complex and in a huge data pile. So what they're using our sort of streamlined data refinery for is to be able to single out that little bit of data and only process that little bit of data
so
where they think fraud. Find where we think the anomaly might be, and then pull it out for further analysis. Identify it for further processing.
We've had another question come in. So, how will the incoming GDPR rules affect organisations' data preparation or their use of data?
Well, so I'm assuming we're talking about privacy rules here? Yeah. So those privacy rules, they're going to demand first that data is governed and that we know, when I say governed, I mean that we are providing authentication rules to access the data. But it's not just about accessing data, it's about knowing where the data physically is and which computers it's sitting on, which disks, which machines are processing it, which processes are taking place against it, which calculations, et cetera. So it's going to affect, because you're going to need to be able to trace that whole thing. So what you're really looking for are platforms that expose all of that metadata. When I say metadata, I mean data about data, right? So we want to be able to know everywhere that data went, everything that happened to that data, every calculation that took place. So those rules are going to seriously impact that. It's going
But
to.
I guess data preparation actually helps with the governance, because preparing your data, you're actually readying it also to find any anomalies, as you mentioned earlier, but also to find that it's all structured in the right way and that, you know, kind of adhering to governance rules. It's
a little more than that. So there could be compliance rules that a bank has around reserve or liquidity or whatnot. But if we're talking about things like data protection, what we need to know is, what are those calculations? Data prep can't happen in a vacuum, right? What if somebody just made a change and threw the data in? We need to be able to track what change happened, how it happened, when it happened, where it happened, who did it, and so on. So it is authentication, authorization, and so on. So really what you need are tools that surface all of that metadata, all that processed metadata.
René, would you agree with that?
Well, yeah, I agree with that. I think it means that it has to be part of your data preparation and your data strategy, and having the tools to properly audit and keep track of what's happening to the data and what you can do with the data where you are, really.
Yeah, exactly.
So it does add more complexity.
We're nearly out of time. We'll have one last question. Do organisations need a massive store of data before they can start using data science or data analytics?
So data science is probably my favorite topic. Data science and machine learning, and I wish I had a blackboard here, I'd start sketching things. But what I will say is this. The idea of applying, what we call data science today has bits of statistics in it and computational analysis, all these different things. The statistics work. We've been doing that for centuries on relatively small data sets. And virtually every company does it. Every time they draw a trend line, that's something we call ordinary least squares regression, right? Those types of things are happening all the time and don't need huge volumes of data. Now, they're more accurate typically when you have more data, but then the more complex machine learning techniques are designed to deal with large amounts of data. When the data is very sparse or there's very low volume data, you don't get a model that produces a great confidence value. So, are you going to get great data models, great machine learning models or data science models out of 50 records? No. At the same time, do you need 5 trillion? No.
It's finding that balance.
Yeah, I mean, honestly, when people are building these complex machine learning models, artificial neural networks and whatnot, they don't usually use billions upon billions of records. They're using thousands or hundreds of thousands.
René?
Yeah, I think this is. I think this shows that this thing can also be an art as well as a science, because it's not just we have to process X amount of records, but we kind of get almost like a gut feeling that maybe this is not enough data, or maybe this is too much data, or maybe I've got the wrong type of data.
You hit on something perfectly there. Sorry, I didn't mean to interrupt you.
No, please.
The reason I'm saying this is because when we have this data science world, there's 2 approaches we have to it. One of them is very formulaic, things like regression, and one of them is kind of black box, and that might be something like artificial neural networks. And the artificial neural networks, there are guidelines and there's an art to picking how many nodes or how many layers. When we talk about deep learning, how many layers are in the network, there's an art to that, right? On picking whether it's a ReLU function or a sigmoid function or whatnot. There's such an art to this that we don't know in advance. So knowing the amount of data in advance is also one of the challenges. Do we process all the data or do we process 2% of it, right?
Exactly, and it's kind of like saying, well, we'll try this. Did that work? No. Okay, we'll try this. Did that work? No. Did we try this? Yes, that works. And that is evolution.
Yeah. Which, by the way, is a core element of modern AI techniques is things like genetic algorithms, where the system is self-evolving.
Yeah.
Lovely. Fabulous. Wael, Mene, thank you so much for your time and joining us today.
My
Thank
pleasure.
you so much for watching, and hopefully we will see you again soon.